Well, I'm hoping you're all in the right class today. So we're going to go over the 2024 International Residential Code update and overview, kind of looking at the changes from the 2021 mainly to the 2024, but also going to cover a little bit of the 2018. So with that, let's get going. All right, as you've heard a little bit about me, currently I hold the position as Senior Plans Examiner and Code Consultant with Shams-kota. So I help architects and engineers make sure they get the right things in the plans and those kind of things. Actively involved in the code world and participate in a lot of committees and a lot of the uh, code writing and code development process. So the ICC Codes and Standards Committee, if you don't know what that is, they're the ones that choose the people that are going to actually be on the panels that help change the code. The committee actions, those that sit on the committees for the action hearings where we change the code. All right. So today we're going to talk about the significant changes between the 2021 and 2024 IRC. Going to cover chapters 1 through 10 and look at what the intent and the impact of the changes for everybody, not just for the inspectors and the plan reviewers, but also for the designers. And we're going to go through the restructuring and some of the tables that were moved in the codes. So the first and biggest thing is probably there's a new format with the codes. So they are going to be more of a book read rather than the two columns that we've seen in the past. Similar to what we've got online. I'm sure a bunch of you use the iCodes that are available online, whether you've got a premium subscription or something like that. This is the biggest change in the new format. So if any of you got the 2024s, you have already seen this. Another thing, we've got the revisions. You can scan the QR code and go from there along with the 7-digit code underneath and get right to the changes to that section. Now, if you're using the online versions, those changes are all in blue, and so they're really easy to find. If you're using premium, you got a premium subscription, you can also see the code changes and click on the links to show you what the proposals were and what actually went through and how much it passed through what the code officials voted on it actually, to see if it was a roaring change or if somebody decided that they didn't like it too much and it barely squeaked by. All right, so a couple of changes to the purpose of the code. Just real quick here to provide a reasonable level of safety and health, and then also to that just keeps things consistent through the code, showing that, hey, we want to make sure that we're not going too far above and beyond, because we need to remember that the codes are a minimum. They are not the above and beyond standard. They're just what we want to keep everybody safe. All right. So what we added in the 2024 was we added change of use to the IRC. So what that means is we've got additions, alterations, or changes that make it into a different use or an occupancy within that same group. So we could go through an R3 residential home to an R3 boarding house or an R3 what's the word I'm trying, lodging. So where we use like a bed and breakfast, something like that. We're changing within the same scope, but still doing a change of use. With that, we need to comply with the IEBC for those. Equivalency criteria. So this is pretty simple and pretty easy to follow, I think, where we're looking at alternative materials and things like that, where we haven't seen them before or they're new, those kind of things. We need to have an evaluation that shows what it is and that it meets what is specified in the code. And that includes quality, strength, effectiveness, durability, safety, other than fire safety, obviously, and then of course fire safety. So if we got new smoke detectors or something on the docket, or something new comes in where it's some type of new residential HVAC system or something like that that we haven't seen before or isn't included in the code, that's where we use this equivalency to say, hey, yeah, it matches and meets all of the prescribed things in the code. All right. Evaluation reports. I'm sure you guys are all familiar with these. When I was working in Broomfield, the city and county of Broomfield over here in Colorado, we required a lot of these for most of the materials that were going into new homes and into commercial constructions. Now that just means that it's a third party that's looking at it and saying, hey, this is good to go. And so when we get plans and things like that from architects or engineers, it helps us a lot to have those evaluation reports included. If it's a new product we haven't seen before, or if it's something new on the market, to say, okay, we've got what we need from either the ICC evaluation services or through UL or some other one like let's see, we got ICC US or ICC ES, UL, and also Intertech. So if we get those reports, it helps us immensely when we're going through reviews for new products. All right, a few new definitions popped into the 2021 and the 2024 codes. We have what's called a BIPV, which are your building integrated photovoltaic coverings. Those will be like your shingles and things like that that are solar ready or anything like that, where you pop them on the roof and they actually act as a shingle, but also do solar. So that would include also the building integrated photovoltaic panel, those kind of things where they're bigger, not just the shingles, and also the photovoltaic system. So we're looking at all of that together to see how it's supposed to work on the roof, those kind of things. So we added those definitions. All right, this one with intermodal shipping containers, we updated the code section in the IRC and the IBC to say where it is referenced. Now, I'm not sure if any of you have dealt with a lot of the, oops, I went far. Don't know if any of you have dealt with intermodal shipping containers. In my last jurisdiction, I was working for Grand County over in Utah and in the city of Moab down there, and people were trying to build these all the time. Say, hey, we want to repurpose these and we want to use these. What can we do? And so we want to look at 3114 in the IBC for the International Building Code to find out what needs to be done with those. For the most part, it's just ensuring their structural integrity and making sure that they are attached and anchored properly. So now a couple of upgrades here for seismic restraint for appliances. Just includes for seismic designs D0, D1, and D2, we added in townhouses in design category C. So real simple change there. Whereas category C used to be completely excluded, we've got it included in the codes now. And just for townhomes. Exterior walls. All right. Now, plenty of you, I'm sure, through your design process have had to deal with a lot of exterior walls. So these are going to be based on fire separation distance for dwellings and townhouses, and need to be done in accordance with, if we're going to do in a sprinkler system, either 2904 or we can use the NFPA 13R. But our distance and things like that, we need to separate those. Pretty simple, pretty straightforward, just a little more clarification and adding in townhouses, not just single family dwellings. So that would include the garages and things like that that you see in big townhouse complexes and stuff like that, where they're separated from the main bank of homes. I actually lived in one of these for quite a while when I was first getting started, and my garage was separated, but it was like 15, 20 feet away. So we weren't worried about that. This is talking more about where we've got maybe 5 to 10 feet or less where they're right next to it. All right. Now, with this, we've got a clarification and more information on how we determine the separation distance. That can be whether it's on the same lot or if they're on different lots. We can just choose to put in an imaginary line, or we can use the lot line. Just depends on where we decide to draw that line. So we could have this one house on the right, the red block on the right, could be right up next to that line. We would just have to make sure that we rate that wall that is right on the property line. That's more along the same lines. Just need to comply with 302.1. And there's a couple exceptions that get into here. One of the big changes, we're looking at accessory buildings pretty intensely now, just because we've had some issues with fires and things like that transferring to different structures and whatnot. So that's just something to keep in mind as you're going through the design process. Structural independence. This has been in the code for quite a while now. Not a big change between the 2018, 2021, and 2024. They need to be constructed still structurally independent, but we've included an exception where townhouses are protected by an automatic sprinkler system. So it used to say fire sprinkler system in the 18 and the 2021, or the 2021. But we've updated it to say the automatic sprinkler system complying with either P2904 or NFPA 13D for the dwelling. And I did say that we could use 13R, but I misspoke a little bit earlier. It should be 13D for dwellings. All right, two family dwelling units. They got to be separated from each other either by 302.3.1 or 302.3.5. And that's regardless if there's a lot between them. That's where we're drawing that imaginary line like we just talked about on a few slides ago. And those ratings need to be at least an hour or a half hour where they're equipped with an automatic sprinkler system. And we got to make sure they comply with either ASTM E119 or UL 263. Or we can use 703.2.2 of the IBC to help us with that. Now, one thing to remember is that as we're going through residential stuff, we can always jump into the building code and pull some things out of that because it's a more restrictive code on the commercial side. And so building officials, plan reviewers are always okay with you pulling in the IBC. All right, vertical assemblies, they have to extend and be tight against any combination of following. So we got the foundation, horizontal assembly, whether that's your floor or your roof, or the underside of the roof sheathing. And then the ceiling beneath an uninhabitable attic would need to be constructed not less than 5/8 type X and a draft stop between the units. Okay, now remember this is between our two family dwellings. Makes it easy, right? And the structural framing supporting the ceiling can be protected by less than 1/2-inch gypsum board or equivalent. All right. So we've got shared accessory rooms. This would be where we've got a shared laundry or something like that between two units. We just need, the code has given us a new table of what's requiring or I guess I misspoke there, but what's required between those two to make sure that those are protected. So that would be whether we got an attic or rooms below or above whatever shared room we've got, whether it's a common area that's built into the townhomes or into the dwelling units. They just have to meet this table and have at least the rating that is required there. Not less than 1/2-inch or not less than 5-inch for habitable rooms above or below a shared accessory room. And that'll be type X, of course. All right, so we've got a new exception to R302.13 where we've got floor assemblies that are not required to be fire resistance rated. Wood floor assemblies less than 600 square feet within detached accessory structures with no habitable space above them. So this just kind of gives some clarification, say, hey, you're 600 feet, you're 600 square feet with a detached accessory structure, then we're not going to need to worry about fire rating that wood floor assembly, right? And one quick question, if any of you want to type into the chat here real quick. Let's see here. Q&A feature, where's the Q&A? It's going to see if there are any. Oh, there it is. Perfect. All right, I found it. Okay. I apologize, everyone. And so just where would we find it? Where would we go to determine if there's any equivalency? What could we use as that? There's always new products out there that could say, yeah, this is fire rated or not fire rated, depending on what we've got. And so determine the equivalency, we go back to where we were in chapter 1 to figure out what the definition of equivalency would mean. So I am just giving you that answer. All right. Storm shelters. I'm sure we see tons of storm shelters in Nevada, because it's always so stormy and there's hurricanes and everything out there. Um, but those where we have them need to be constructed in accordance with ICC 500. And so that's just an updated reference to say, okay, these need to be constructed this way or that way and go from there. I know in Nevada you don't have too much going on. It's much like Utah and Colorado, so it just gets hot. So maybe you need a storm shelter to get away from the heat. Smoke alarms, updated some information on how they need to be installed. Most of that just means, hey, we got to install it per the manufacturer's instructions. If they say they can put it on a sidewall, go ahead and put it on the sidewall or on the ceiling. Or if it specifies that it has to be further away from a cooking appliance, those kind of things, we're going to be looking at more of the manufacturer's instructions for what we need. We also added a location of where they need, a location of where they need to be in regards to sleeping lofts, because we're starting to see those more and more because of tiny homes and those kind of things. It's just got to be within the room the sleeping loft is open to, or in the immediate vicinity of the sleeping loft. So you might need a two in there, you might just need, if it's open to the other one. So a lot of times I've seen it when I was doing inspections in Moab, we'd have somebody put a loft that could be used for sleeping in one room or another room, and leave a partial wall between them where it was open from the loft to the room below, but it wasn't a full, complete blocked off wall. We just have them put one smoke detector between the two just to make sure that they were protected. All right. Installation of your cooking appliances. So this again gets back to manufacturer's instructions, but there are some exceptions in the code. This is the change from the 2018 to the 2021. You can put them not less than 6 feet horizontally from a cooking appliance. So we need them at least 6 feet away from the range or something like that, except where it's necessary to comply with R310.3. So if you would eliminate it, because it's everywhere around that is 6 feet, so we're talking tiny homes or some small spaces where got studio apartments or something like that that we're looking at, where it would make it less than 6 feet. But if you kept it 6 feet away, it would eliminate it completely. That just says, hey, you can do this, but you can't eliminate it completely. That's just to get rid of nuisance alarms and things like that. Because we don't want people taking their batteries or taking the smoke detectors off the wall. I've seen plenty of remodels and houses where they end up just taking those out because they're making noises. All right, a couple of new sections in the 2024. We've got R316 that talks specifically about habitable attics, and they got to comply with 316.2 and 316.3. And it's got to have a floor area and section with in accordance with R304, which gives us, our proper area, and ceiling height in accordance with section 305, just to make sure that we have enough room to walk around and be around in it. If we're going to be in there, we got to make sure you're not hunched over and those kind of things. Now, there are provisions in those sections for your knee walls and your side walls, and how low that can get until you get to that point. But that's just that there. Habitable attic is considered a story above grade plane, but it won't be if it meets all of the following. So this is a completely new section in 2024. And the aggregate area is not greater than 1/3 of the floor area below, and not greater than half of the floor area below where the attic is located within a dwelling unit with a fire sprinkler. So if we got an automatic sprinkler system in there, we get to go half. Otherwise, we have to be stuck to 1/3. All right. The space is enclosed by knee walls, assembly above, and any of the floor ceiling assembly below. The big change here is an automatic sprinkler system in accordance with P2904 for a 3rd story. So that would be if you've got an habitable attic above the 3rd story of one. I'd see in Colorado they're doing a lot of. Let me back up here a little bit. So in Colorado they're doing a lot of houses where they do 3 stories, and then they make a habitable attic on top of that. So this would apply here just because land is so expensive out here. They're trying to maximize how much land they've got and how much space you can get on a land. So they're building up instead of out these days. And so this is where we would pull in this code section. It would just have to be protected either by P2904 or NFPA 13D. Those are pretty much synonymous in the code. There are a few differences, but not too much between those two sprinkler designs. So if you're designing anything that has this up there, this is gonna affect you. Our means of egress, it's got to comply with R311, which means got to have proper stairs, got to have everything that we normally would have from another story. So a couple additions into 318, which is our stairways, and means of egress. We're looking at ramps, landings, hallways, those kind of things have all been included in 318 now. Our stairways, obviously, we need to make sure that we get them in compliance with 318-7. Now, we have a couple exceptions there. We don't need stairs that serve a building, porch, or deck, or non-habitable attics, or crawl spaces. And so here's a quick question. When is an underfloor space a basement or a crawl space? And I guess it depends on the jurisdiction, right? We have certain provisions that kick in for a crawl space. A basement, so you could have a crawl space that's 8 feet deep, right? That doesn't necessarily mean it's a basement. It becomes a basement when we add habitable space or anything like that down there where we say, okay, we're going to utilize this space. So even if you start using your crawl space for storage, it's not necessarily considered a basement and it doesn't need to comply with the energy code or the other provisions of this code with the IRC or any of that. Now, even if we put water heater or HVAC equipment down there, furnace, those kind of things, it does not necessarily kick it into the basement. All right, so we added a new section into 318.7.9 where if we alter existing stairs, they don't have to comply with the new code. That means we don't have to upgrade them or give them more headspace or anything like that. So this is copied straight from the IEBC, just more of a code correlation type alteration and update for this code, just to make sure that, you know, we got some of those old homes that have those super steep stairs that go down into what used to be probably a cellar that they turned into livable space, and you don't quite have the head height or the proper tread depth or tread height. Ramps, obviously, this is pulled more from the IBC and those kind of things, where we're looking at ramps for residential accessibility, those kind of things. Obviously, we want to have them with the proper slope, but if you can't make it with the proper slope for what's required for ramps, you can do a slope not more than 1 and 8. That's a pretty steep ramp, 1 and 8. Definitely not what's pictured here, but that's just saying, okay, maybe you got some site constraints or other things that stop you from being able to put in a regular ramp with the proper slopes. All right, emergency escape and rescue openings. So a lot of the changes that we've seen with the 2024, where we've added in sleeping lofts and those kind of things to these. We got to have access, obviously. So in this picture here, we've got a sleeping loft that's open to what looks to be a kitchen down below, correct? And we got to have an egress out that. Same goes for basements, unless the exceptions, the exceptions are if the basement's only used for mechanical equipment and the floor area is less than 200 square feet. So that hasn't changed much. We just clarified that basements and storm shelters that are included are constructed in accordance with ICC 500. So we don't want, if it's going to be a storm shelter to get away from hurricanes or anything or tornadoes or something like that, then we don't want to have windows and things like that are going to break or have debris flying through. And so the ICC 500 will be the governing document there. And we added that in as a second exception. All right, now we've got some updates there with how the minimum dimensions need to be looked at, just an updating and restructuring of the code. So we've got 319.2.1 and 319.2.4. Those sections are going to govern what our minimum sizes and what we need for rescue and emergency escape openings. They reformatted that section in 2021, gave a little more clarification, then they moved it in the 2024. So if you remember, this used to be, oh, I just forgot. I blinked on that one. I want to say it used to be 310 or 309, but I'm not entirely, I don't remember that one now. But they moved it to 319. So it's confusing me because they've moved all these things around in the code. The 2024 did a lot of restructuring and moving things around to the IRC. Window fall and protection device. They got to be located in accordance with R319.1.1 or as low as the device can be installed within the existing clear opening. This is where we've got issues on the second floor, people falling out the windows, things like that, where it is close to the floor and those kind of things. Don't want to have a bed right next to the window where somebody can roll out the window. All right. Again, this is more along the lines of the restructuring of 319.7.1. So where we have a change of occupancy, the emergency escape and rescue opening would need to be installed in accordance with 319.1. So if we've got operable windows serving as the emergency escape, they got to comply with the following: live work units. Only the the non-residential portion shall be accessible in accordance with sections 508.9. Oh, wait a minute, I just went back to that. The following. Okay, yes. So live work units, we've got so let me jump back to that one. Apparently some of my slide got cut off. The emergency escape and rescue openings, obviously, if we're putting them in a change of use, say it's just a storage basement right now. If we've got a window down there, there are provisions in 319.7.1 that allow for certain sizes of windows. If we're going to replace the windows, then they need to at least meet the same sizing as the others. So let's talk about live work units. Live work units, the non-residential portion shall be accessible, so that means we got to put accessibility into it per the IBC. And in the building where more than 4 or more live work units, the residential portion of the live work unit needs to comply with 1108.6.2.1 of the IBC. Now, if you remember, chapter 11 from the IBC is the accessible portions. So we have more than 4, we got to start pulling in for the accessibility provisions. All right, care facilities, 322.3. Where these are constructed, they can be, blah, blah, blah. Oh my goodness. Where care facilities are permitted to be constructed in accordance with R101.2, the portions used as a dwelling to operate the business have to be accessible in accordance with Chapter 11. So if we've got a, this would be such as where we've got a small daycare center or something like that, we can go and add into chapter 11 to make sure that the places that we're operating the business from are accessible so that people can get in from the street and get to the portions of that dwelling. So this is where we've got live work units, those kind of things where we have the person residing in the home but also running the daycare out of their home. So if they lived on the second floor, the first floor would need to be made accessible with chapter 11. So we see kind of a accessibility moving more into residential business. So if you've got a business that you're running out of your home, that's where it's going to need to apply to be more accessible. Private residence elevators, pretty much all the code added in here was that they need to conform to ASME A17.1 and CSA B44 section 5.3. So this just makes it so that there is more of a governing document that controls how residential elevators are installed. I got one jurisdiction over here that we're in charge of in Colorado that it seems like every new house they build, they put an elevator in. And it's a lot of fun to look at what the code requires for private elevators and things like that. Usually up on the higher end of things, you get these elevators. I've seen a lot of them where they actually put in provisions for it for future. They don't put it in at the time of the build, but they just leave a closet or something like that that's easily taken out to put in the elevator. But this would be the governing document, the ASME A17-1 or the CSA B44 section 5.3. All right, a couple of updates to our glazing and natural light openings, 325.1.1. So we can, a couple of exceptions to where we can put this. As we know that we're building buildings closer and tighter, we just need to make sure that they can face onto a roof, porch. The exceptions are we can face onto a roof, porch, deck, or patio in a street, alley, or public way where the longer side of the roof not less than 65% obstructed and the ceiling height not less than 7 feet. They can face into a sunroom, adjacent to a street, alley, public way, yard, or court. So that's a pretty big change right there. If we've got an opening or someone wanting to add an addition of a sunroom or something like that on the side of their house, you can have your natural light come from that area. And of course, glazing or openings aren't required where we got artificial light that can provide 6-foot candles over the area of the room at 30 inches above the floor. Eve projections are not considered as obstructing the space of a yard or a court. All right. Ventilation, we got a couple of revisions to the exceptions for our natural ventilation. This would be, you open your window, there's natural ventilation. It's not required in habitable rooms other than kitchens where a whole house mechanical ventilation system or a mechanical ventilation system capable of producing 0.35 air changes per hour is installed. All right. I think I'm a bit further. Okay, so we have some updates to our continuous footing requirements in seismic design D0, D1, and D2. We have a whole new table in the IRC where we pull the information that we need. Okay, now if we look through this, continuously fully solid graded concrete and masonry footings R403.1.3 required for an R. So in D0, it doesn't matter if you're 1-story, 2-story, or 3-story. You have to have a continuous footing supporting exterior walls, okay? Supporting interior required braced panels. For 1-story, we get a little bit of a break. It's not required, but if we're greater than 50 feet, then we need it. Same with the 50 feet or less. For 2-story, not required to have those interior footers, but as soon as we get up to 50 feet and 3-story, any of them are required to have that. Pretty simple, pretty straightforward. It's just a little more guidance in the code. So when we're doing designs for our high-risk earthquake areas, we want to make sure we've got the proper stabilization in place. All right. Don't know if any of you are familiar with the crushed stone footings. I personally haven't seen any in my days. Mostly what I've seen is cast in place concrete footings. But we've added some more information on what is allowed and how we can do with crushed stone, those kind of things. They just have to be done in accordance with 403.4.1, and they are permitted for non-retaining cast in place concrete forms that comply with R404.1.3 and this section, okay? And we added a couple of new figures and some information about townhouses and where we're allowed to use crushed stone footings or cast in place concrete foundations for seismic design categories A, B, A and B for townhomes, and 1 and 2 family dwellings in A, B, and C. All right, floor framing supporting guards. So we got a little more information on this. So the 2021 said where supporting guards not exceeding 44 inches height, they shall be engineered or done per section 502.11.1 or 11.2, or we use conventional edge framing. So, or we use timber edge framing. So where we're using trusses and I-joists, this is where the 2024 code came in. So the other changes, those sections and information was given in the 2021 code, so 2018 to 2021 for the stuff in white. And then the yellow is the changes from the 2021 to the 2024. So where we're using trusses and I-joists is edge framing members. The effects of the guards shall be specially considered in the design of the edge member. So we don't want anything overturning or if it or causing any structural instability for the floor. Oh, how'd she go? But yeah, okay, perfect. Okay, so a couple of updates to our deck information here. I'm sure a lot of you probably see a lot of decks that are built. I know I've seen plenty, and there's always a problem with them, and they always try to separate from the building. And the code's trying to change that. We've got a little more clarification on how you're supposed to drill those holes for fasteners and connectors into columns and the beams. The holes for the bolts should be 1/32 inch or 1/16 inch larger than the bolt diameter. And then the connectors have to be installed in accordance with the manufacturer's approved instructions. So the code is always relying on and pushing for the manufacturer's instructions. So that's how things are supposed to be put in. That's how they're supposed to be used. And more specifically, that's how they were evaluated and tested. You put something in a way that it wasn't tested for, it'll probably fail, or it won't function the way that it's supposed to. And that's what we're concerned about. Right. So we've got a couple of changes in the 2024 for our tables for maximum beam spans and deck spans, maximum deck beam spans. Table 507.51. We've updated our joist spans and given cantilever length added onto it. So that's what the and is, okay? So for 6 foot, 6 and 0, 6 and 1.5, that's what we've changed in there. So added some more information for what Southern Pine is allowed to do, depending on where it's at. So if we're 6 and 0, obviously we go to the table here, we can look at it. We've got two 2x6s, we can go 7'4" for that beam. If we've got 12-foot span, so if we're looking at 12, we're going to be looking at 12 and 0 or 12 and 1, 12 and 2, 12 and 3 with our cantilever, right? So if we do a 2-foot cantilever, oops, let me go back here. If we do a 2-foot cantilever, that means we would be in the 6th column over and the 4th line down in the top, and we just follow that down to whatever we want to use with Southern Pine or any of the others. So if we're using two 2x12s for that length, we can go 9 foot. Hopefully you can all follow me on that table. Can you all see my mouse over there? I hope so. So I was talking here, if we do 12 and 1 or 12 and 2, we follow down here to two 2x12s, we get 9 foot.
Oh, this is Monica. We do see it.
Okay, perfect. I'm gonna put the mouse over there so that I'm sorry everybody, I'm using 2 screens, and so I got my presenter on one and the presentation on the other. So I will keep my mouse on this screen so you can see what I'm pointing at. I haven't pointed at anything yet, but all right. So we got a little more information on our braced wall panels and how to actually calculate where that is to be from. So the nearest edge of a braced wall panel shall be located within 10 feet from the edge of a braced wall line. So we need to start that braced wall within 10 feet of that wall line. All right. So we got 10-foot max here. So you can see where my mouse is. We got 10-foot max before we get that braced wall panel. And same on this side, 10-foot max. All right. The distance between the edges can't be more than 20 feet. So right here, I know this drawing is a little fuzzy, but you got 10-foot max here to where this braced wall panel is, and then 20-foot max here that we can go across here. So as your engineers, or if you're doing the engineering as the architect, be aware that as we're throwing in shear panels and things like that, that's what we'll be looking for those braced wall lines. Okay. There are a couple exceptions with the braced wall panels, and obviously in the higher seismic categories, D0, D1, and D2, we're going to need to comply with section 602.10.2.2.1. Did I put too many? No, two. Braced wall panels in A, B, and C seismic categories will be with 602.10.7. So if you design it to those, then you'll be fine. All right. Garage doors. Pretty much all this added was that they just need to be installed in accordance with manufacturer's installation instructions. Pretty simple and straightforward. Whether or not we're using special ones, insulated ones, or just a regular garage door, they need to be installed with per the manufacturer specifications. This is just making sure that all the safety and everything else that's supposed to be in with the garage doors is still in place for them. All right, so R701, we went through that a little bit earlier. Section R701 was relocated from before to R601.1. That's where we're looking at more of the restructuring of the 2024, where they've moved things to where they apply more readily and better in those locations. So the 2024 IBC did a lot of the same. They moved some tables around it, did some things like that, and adjusted some sections. So like we saw with the glazing requirements and emergency egress openings, they moved sections around. So 701 got moved to 601.1. All right, you guys are tired of hearing about vapor retarders, I'm sure. We're starting to see these more and more in the code as they apply to energy and are important for those type of things to make sure that we've got air movement or no air movement, depending on which climate zone you are in. So they got to be made of a material that's classified in accordance with the table R702.71. It's got to be provided on the interior side of the walls, as indicated and of the class indicated in R702.72, or you can use an approved design by an accepted engineering practice for hydrothermal analysis as an alternative. And they have to be installed in accordance with R702.7.2. And then obviously we're going to be looking at the climate zones in accordance with. So we're in the IRC here, so we're saying section N1101.7, which is our energy provisions for the IRC. Now that doesn't mean that you can't go to the full energy code and use the IECC, the International Energy Conservation Code, as your governing body and use the residential chapters from there. Those are the same. They pretty much copy and paste the IECC into the IRC, which is why it took them so long to get us the 2024 IRC this time, because the standardization process for the new IECC took a little longer than the typical process that we see. All right. So we got a couple exceptions to these vapor retarders. Obviously, we don't need them on basement walls. The basement walls should be waterproof from the outside, and that waterproofing will act as the vapor retarder as well. Usually the waterproofer, so no vapor or anything gets through that. The below grade portion of any wall, so this we're talking about where we've got walkout basements, those kind of things, where portions of the basement wall or the wall is partially in the ground. So this could be crawl space walls, those kind of things where they're going to be damp proofed, which is going to stop the entrance or movement of air. So concrete, whether whether you believe it or not, is unfortunately porous. So water will eventually get through it and air will eventually get through it. For the most part, it is sealed, but sometimes there are those pores that actually let water through and air through. Um, Construction where accumulation, condensation, or freezing of moisture will not damage the materials. So if you're in a super, super dry climate, or things like that, or if you are going to, like a shed or something like that, where you're not going to have any condensation or freezing that will damage the material. Vapor retarder not required in 1, 2, and 3. But in climate zones 4 through 8, a vapor retarder shall not be required where the assembly complies with 702.75. So typically you'll see that, like I know in Colorado we see it a lot, but if they build an assembly in accordance with 702.75, then we typically don't have to have it. Now there is a caveat to this as well, because the wall does need to breathe. It's got to have the ability to push through wet, so there isn't moisture trapped in the wall, and so it's not condensating on the inside of the wall. I saw this happen actually quite a bit in Moab when we started requiring the vapor barrier on the inside of walls. We'd throw up plastic, and then they'd put the drywall on top of the plastic and seal all those openings. But what was happening is the moisture in the air from cooking, from showering, those kind of things was actually passing through the drywall, and there wasn't enough insulation or the wall wasn't properly sealed on the outside, and it would condensate the water on the plastic and it would run down and rain inside the house. And so we had people that the bottom of their walls were getting all wet because of condensation issues. And that's what we're trying to avoid here is we want to make sure that we don't let water vapor into the wall cavity, but if it does get in there, we want to have it able to get out, which is why materials like Tyvek and those kind of things allow for water vapor or water to transfer from only one way. So if you've ever seen a demonstration with Tyvek where they put it on or they fill it with water from one side and it slowly leaks through, but if they fill it from the other side, it doesn't leak at all. And that's mostly because of the design of the Tyvek paper, but that's also to make sure that your wall breathes. The insulation helps making sure that you don't have any issues with condensation, which is why a lot of times in the higher climate zones 4 through 8, those kind of things, you've got more insulation in the walls as to prevent that condensation. Right. So here's our new section, R702.7.2. Vapor retardant installation, they got to be installed per the manufacturer's specifications, or accepted methods or an approved design. So if you come up as an architect with a design that will work, we can accept that. Now, if we go back and remember what the definition of approved is in the code, that basically means that the building official says it's okay. So anything that is approved, whether it be a third-party material or a new material or a design, the building official has to sign off on that. Okay. Where the vapor retarder functions as a component of a continuous air barrier, the vapor retarder will need to be installed as an air barrier in accordance with N1102.5.1. Now we're going to get into energy here in a little bit, so I know that's always the bane of everybody's existence, and I always see comments go back to architects and engineers when it comes to vapor, or it comes to energy stuff. All right, a water resistant barrier. So typically this is what we see on the outside of the building. This will be your Tyvek, this will be your ACE house wrap or things like that. That becomes your weather resistant barrier or water resistant barrier. So we need not fewer than one layer over the studs or sheeting on exterior walls. I know that out here we build mostly with We put sheeting on almost all the walls out here. I know that down in Texas they don't do that, where sometimes they just put the weather barrier over the top of studs and only do braced wall panels, those kind of things. It just depends on your different locales. Nevada, I am not entirely sure what you guys do over there. I think it's very similar to what we do here in Colorado and what I did in Utah. So, but that just needs to be that weather resistant, water resistant barrier needs to be put in a manner, in a way that it's behind the exterior wall veneer and behind deck ledgers. So, a lot of times we'll see exterior decks that just get attached straight to the siding or something like that, where we don't have any weather resistant barrier. And we've got water that comes down and sits on top of that deck ledger, and eventually it rots it out. And then that deck fails ultimately. And so this is to make sure that we've got um, we're not we're not bringing in straight from the deck to the home. Another case that I saw when I was doing inspections in Moab was we had um, a new deck that was going in, and they decided that they wanted to extend it a little bit. Now, this was a new build, and they had already put the weather barrier on the section that they wanted to extend into. And so, but the first section didn't have the weather barrier behind it. And so we needed to make sure that they put that there. Now, a lot of times what we'll see and what the code requires. So we want to make sure that that wood is protected. And so what we'll see in the code and what we should see in the design is a detail that shows that ledger going on top of the water resistant barrier, and then also a flashing that sits on top of that ledger to keep water from sitting on top of it. Now that means that there would need to be a break in that water resistant barrier and that flashing tucked up underneath to make sure that functions right. But we want to make sure that no moisture can migrate back in or get through any of those wood components, whether they're attached into the side of the wall or anywhere else. All right, where it also functions as the air barrier, it's got to be installed, of course, with 1102.5.1 from this code. And some of we got an update to the materials that we've got here. So if you look here, we got 15 pound pellet, which what we see a lot, what weather resistant or water resistant barrier started out as. It's got to be listed to ASTM E2568 as a type 1 or type 2. But we've also got foam plastic insulating sheathing, water resistant barriers complying with 703.1.1 and installed in accordance with the manufacturer's instructions. So this is a new method of compliance for the water resistant barrier. Now this would include things like zip sheathing, those kind of things where we've got the foam attached actually to the sheathing, and then we attach it to the wall. Those kind of things, and they just got to make sure we put them in, install them in accordance with the manufacturer's instructions, and they comply with our 703.1.1. Now 4 and 5, those are still the same sections that were in the 2021 and 2018. We are just moved them down as we added the foam plastic. And we do have a new exception to 703.2, and it's not required for unconditioned tool sheds, storage sheds, playhouses, those kind of things, and similar accessory structures where we meet following requirements. Okay, the exterior wall covering limited siding that is attached direct to the studs. Exterior walls are uninsulated, so if you got somebody who decides they want to try and insulate their attic, obviously you would need some water resistant barrier there, because what's going to happen is that the foam is going to stop it, or the insulation, those kind of things are going to help it cause condensation and create rot in those walls.
Well, this is Monica. I'm sorry to
Sure.
interrupt. Someone has a question
Sure.
for you. Is there a minimum overlap requirement for the water barrier over the flashing for the ledger?
Typically, we're looking at 4 inches on that. And that's pretty standard across the energy or the industry, I should say, for flashing and those things like that. So whether you've got a weep screed or something like that down to the bottom of a stucco wall or a stone wall, those kind of things, 4 inches is pretty much the standard in the industry. Now there are provisions where you can shorten that. It just depends on how the material is put together. So the least amount you could do is 2 inches though, but typically it's 4 or more.
Thank you.
No problem. And the reason for that is because most of the time, those flashings, the manufacturer wants a 4 inch attachment flange. And that's the only reason why, is they just want to be able to have enough that you have to nail into, whether it's studs or sheeting or the bottom plate on a home. All right, and then so back into those accessory structures. Obviously, you can't cover the interior side. So we're talking about open sheds that have open bays and things like that in them that don't have any drywall or anything on it. So as soon as you enclose that cavity, you create a possibility for condensation and those kind of things. So you don't want to have anything that might capture moisture and let it condensate and create rot or mold or any other type of hazardous stuff in there. All right. Stucco. Do you guys see a lot of stucco in Nevada? I'm assuming you do because it's nice to have that extra layer of insulation on the outside of the wall to prevent heat and cold from entering in. Um, so these we changed the and from or the or to and in 703.7.3. So they have to be installed in accordance with 703.2, which we just went through, and comply with 703.731 and 703.7.3.2. So we've got a new exception to those sections where these don't apply where the construction where where accumulation, condensation, or freezing of moisture will not damage the materials. So that's just bringing it in line with where we talked earlier about the water resistant barrier and where it should be installed. So that's pretty much just making sure we're in line and correlating the codes. All right, and dry climates. Okay, so this is another one. The water resistant barrier shall be a 60-minute grade D paper or have a water resistance equal to or greater than one layer of water resistant barrier complying with E2556 from ASTM type 2. Okay. Now, it's got to be separated, so we're still in climates, right? Or in a stucco, right? So this will apply to Nevada, where we've got our dry climates. The water resistant barrier is separated from the stucco by a layer of foam or insulated sheathing with a non-water absorbing layer and a drainage space or a means of drainage complying with 703.7.3.2. So a lot of times we'll see guys just throw stucco or I always caught, when I was doing inspections, I always caught the stucco. We're trying to do stuff that never worked. So where we're putting that bead foam, the white foam, or using any other type of material on an exterior wall, we should be providing a drainage plane for that. So if in your designs, if you're calling out for a stucco wall, you're gonna need to crawl out for a type 2 paper, which is, so when I think of a type 2 paper, I'm thinking of that crinkly Tyvek paper, or you provide some type of drainage plane behind it. So I've seen a couple of methods with this. Most of the time I would see the crinkle paper, but sometimes I'd catch the stucco guy trying to use straight flat paper. And then you throw up a piece of stucco on that or a piece of foam on that. And what it does is it creates a sealing barrier right there. And so there's nowhere for the water to go. So it just sits there. And we want to make sure that that water has the ability to drain out. A lot of the stucco manufacturers, if you're following the instructions on how you're supposed to install that stuff, whether you're using Western One Coat or any of those other types of products, whether you're using Stowe or any of those manufacturers, they've got information on how they how you should be doing the stucco. And a lot of those details are good to include in plans and things like that so that the plan reviewer and the contractor knows what they're supposed to do. Now the stucco guys, they always try to get things done as cheaply and quickly as possible. So they'll try and get by without using the drainage plan or anything like that. But we got to have somewhere for that water to run. So whether you're using the crinkle paper or you're using 2 layers. So if you use 2 layers of the type D paper, that creates a slip joint where water can drain through. Now, if you're trying to use 1 layer, they make notched foam. They make little spacers that you can install behind the foam that create a drainage gap, those kind of things. We just want to make sure that we comply with our 703.7.3.2. Okay. Now our flashings, they got to be installed in accordance with 703.4, and they need to drain the water resistant barrier system. Okay. So that's where we're talking when I mentioned earlier about attachment flanges for like weep screed, those kind of things, your stucco products, whether it be stone, because in my mind, if we're using manufactured stone, that's just lumpy stucco. It just attaches pretty much the same way, just has a different look to it. It's still used as cementitious product, still has to have a drainage plane, all of that jazz. But we should have the flashing at the bottom of that wall should drain the water out, which means you've got a weep screed or something with little holes in it that can get the water out from behind the wall. Now, when you're showing details of how this weather resistant barrier is supposed to go together in your plans and designs, you're going to want to show that paper, the water resistant barrier, goes over the top of that flashing. That flashing should never be on top, because then you don't get a good drainage plan out of that.
Well, I have another question.
Sure.
Okay. You're describing an EIFS system, but what about when you call out a 3-coat stucco system with no foam?
So when you're not using the foam, then it can just be applied directly. So you have to use 2 layers at that point. So that's where we're looking at the top one, or not the top one, but that's where so if we go back one slide here, let me back up just a little bit here. So where we're using the foam, let's see, I did have one where we're saying the foam. Here we go, right here. So this is where we're using right here. If you look here, the foam plastic system, we're using that as our barrier. So if you're going to use just a straight Western 3-coat where you're not putting foam underneath it, then you got to have 2 layers of the type D, because you got to create that slip joint. It doesn't have to be type D. You could use 2 layers of stucco if you want, or of Tyvek, just to have 2 layers to create that slip joint. So if you see here where they're using the black paper, right here, our regular felt, or we're using the waterproofing membrane, those kind of things. That's where we're going to want to look to see if we've got the drainage plane. So this is pretty much right here. Water resistant barrier shall be separated from the stucco by a layer of foam plastic insulating sheathing. So we're talking about, yes, like you said, EFIS system, where we're using straight up Western 1-coat. We're going to want to see 2 layers of paper on that to create that slip joint and create a drainage plane. And that's what the manufacturer is going to tell you when they do that as well. Did that answer your question?
Yes. He says yes, thank you.
Can you see the question and answer thing when I pull it up on the other screen? Or is that only for my eyes?
It's just for you. Yeah.
Okay, I just wanted to make sure it wasn't covering the presentation. I'm sorry, everyone. I'm still new to this virtual. I've attended classes before, but I've only taught a few, and so every company uses something different. I've used WebEx before when I was using this, so I appreciate your patience with me. All right, so let's move on from our flashing. Here we go. Any of you ever used fire retardant treated wood in your buildings? you see this a lot in townhomes and that kind of stuff where you bring the layer uh, where you bring the fire wall up to the underside of the sheeting, and then you take 4 feet out from each wall of that common wall and do your fire retardant treated wood. That section's been relocated. So we put it up into 302.15, which is your fire resistance assemblies. So we moved it out of 802.1.5, where it was our roofing, put it into our fire resistant assemblies, which makes a little more sense because now it's not in roofing, but it is in where we're actually going to go looking for fire rated things. So this is just an excerpt right here, this picture from the code where it used to be 802.1.5 was fire retardant treated wood, and the star on the online version just say, hey, we relocated it. So this is what I was talking about earlier. The section changes and things like that are in blue online. Makes it pretty easy to see it. In the actual code book, that's where you get the QR code in the margin and say, hey, okay, here we go. We got to scan this and play with more technology, which just takes you to the premium codes anyway. So ICC is really pushing you toward the premium subscriptions these days. All right, let's talk about some decking information here. So 905.3.1, we have an update so we're in roof assemblies now. Chapter 9 is roof assemblies. Concrete and clay tile shall be installed over wood structural panels or solid lumber sheathing. And so we've got it used to say only, but now we have a little bit more leeway here where we can use wood structural panels or solid lumber sheathing, or we can use spaced lumber sheathing in accordance with R30 or 803.1 in seismic design A, B, and C. So once you get into the shakier portions of the US, you lose a little bit of flexibility with what you're allowed to do with the code. So wind resistance for metal shingles. So they totally took out a little bit of the section. So what I've got crossed out here is what used to be in the code and they changed. So metal roof shingles fastened to wood structural panels, solid lumber sheathing, or closely fitted lumber sheathing shall be tested in accordance with ASTM D3161, FM 4474, UL 580, or UL 1897. All right. And they got to have and meet the basic wind speed for the area. So this will affect you guys in your design and what you're calling out. I don't know that I've seen too much metal shingles going on. Mostly metal roof panels and those kind of things are what we see out here. And I could imagine that over there in Nevada, you don't see too many metal roof panels either, or metal shingles, because those are going to get really hot. All right, should we jump into energy? There weren't too many changes in chapter 10. And we will talk a little bit about some of the other changes that have been in some of the other sections of the code. For the most part, we have updated. So the 2018 to the 2021, there were a lot of changes in the energy code. And then also from the 2021 to the 2024. So if you all remember, the 2018 to the 2021 code was through the normal code development process. We had hearings, we had public comment, we had all of that information. And we did a 3-year cycle on that to get the energy code up to where it should be between 2018 and 2021. Now in 2021, they decided that they were going to move the energy code to a standard, which means it goes through a different process. Now, in my mind, having been involved in the code development process and everything for quite a while, this was a move to keep industry out of the energy code to try and keep it from being so affected, because you'd have people from the industry submitting code changes and things like that, and trying to get their products and other stuff into the energy code and trying to make it an above and beyond code rather than a minimum. And so if you're looking at the 2018 and you're moving to the 2024, there will be a little bit that has changed, not a ton, not like the 18 to the 2021. I would say that the 2021 code was over and beyond what was required for our minimum energy. But the 24 kind of dials back a little bit of that 21. So that standards process actually helped the code, I think, become more of a minimum code. All right, so we've got our sections here, and I apologize, some of these might not be quite up to date because they have changed the structure of the energy code when they did that. Obviously, new residential buildings have got to comply with 1101.13.5 and 1101.13.1, 2, 3, or 4. So that one I can tell you right off the bat is not going to apply in the 2024. So in the 2021 code, they added additional energy proficiency provisions or additional energy efficiency provisions. Sorry, not proficiency. That were in an 1101.13.5. They removed those in the 2024. And they've now added, we'll see a little further on that they've added some credit type system. So kind of along the lines with what commercial was in, where you get a certain number of credits and you got to attain those credits through different ways of complying. Obviously, the exception to this, new buildings got to comply with the code completely. So anytime you're designing anything, you gotta incorporate all of these. So we've got additions, alterations, repairs, and changes of occupancies in existing buildings. They don't need to comply with 1101.13, 1, 2, 3, or 4, but must comply with 1109 of the energy code. So not too much changed here in terms of how we choose our path. We've got the prescriptive option still, where you just take the base numbers from the code and say, okay, this is what we're going to do. This is what we're putting into it. They did change it to, instead of being the total building performance option, we changed it to a simulated building performance option. A lot of times, and this changes because we don't necessarily know how the building is going to be built. We can try and follow exactly what's in the plans, and they do a simulated, this is how it's going to perform. But as soon when we get the building built, then we know exactly how it's going to perform. And it should be within the parameters that are within the simulated building option instead of the total building performance option. So it's just a word change. It's still the same thing. Still have to go through the same tests and all that that show the simulated building performance option. So again, like I said before, we removed 1101.13.5, additional energy efficiency. It is completely restructured and changed where its location is. So you don't have to add in a high efficiency water heater or anything like that unless you are lacking in credits. And we'll get to that point. All right, so little changes in our energy efficiency certificate. We're looking at the building thermal envelope instead of just the building envelope. So we've added thermal into there. And then the code edition has to be included in that. Obviously, if we're doing buildings from 2012, it's going to need to look at the 2012 edition, those kind of things. So if you're under the 2018 code, obviously you're going to use the 2018 version of the IRC or the IECC, and where applicable, the additional efficiency measures selected for compliance with section R408. And that's straight, the R408 is straight from the energy code. So the R408 is referencing to the IECC residential portions. And then a new requirement, that certificate also has to indicate the location and dimensions of a solar ready zone. So in Colorado here in the last year and a half, 2 years, I'd say, more like a year and a half, they moved to a full-on electric ready system. Where the legislature said, hey, you need to start making sure that every building has these electric ready provisions. And so we started adding in, I was doing a lot of row homes and cookie cutter homes. when I was working for the city county of Broomfield. And because of this new law and new requirement, they started having to add in solar ready areas to say, okay, this portion of the roof is going to be solar ready. And now that information has to be put on that certificate. So this is the certificate that usually gets posted in the house, whether it's near the furnace or near the electrical panel, those kind of stuff. I used to hand them out when I was an inspector too, but they were just we'd make these stickers that you could fill the information in, and then you could stick it on the wall next to the electrical panel or next to the furnace, just somewhere where it was available, so you could see. But that information um, has to be provided on the efficiency certificate now. So if you've got it, put it on there. If you don't, then it obviously doesn't need to be put on there. So Colorado did a lot of other stuff too. Actually required them to run conduit and stuff up there to it so that they could pull whatever they were going to put in there. Some of the homes I wasn't or plan reviewing for, it was an option to opt for solar at the time that they were building the home, or you could do it later. And so some of them were getting solar, and so they knew what kind of system and how much was going to be on it. But that's a special case. Not every build is going to be that way. All right, so not too much changed with our insulation and fenestration criteria. The assemblies, the building thermal envelope assemblies have now added in an F factor instead of just the U factor or the R value. All right. So here we've got our maximum assembly U factors. So this is table N1102.1.2. Vertical fenestration. So this is going to be anything that's above, that's not too, what is it? 35 degrees, I think is what the code says, if I remember right. That's going to be vertical, whereas your skylight is going to be more of your horizontal, all right? But these are our U factors for our fenestration, okay? Unheated slab. So you can the first compliance method that the IRC and the IECC want you to follow is the U factor. So you take the assembly as a whole and give it the U factor. That's what so when you're putting stuff in your designs and you're calling out for the U factor of windows and the U factor or the insulation of walls, those kind of things. You can use an assembly U factor and say that, okay, so I've got stucco on the outside, I've got R21 insulation on the wall, and I've got 2x6 studs, and then I've got 1/2 inch drywall. And that stucco on the outside has 1.5 inches of foam. That assembly U factor would need to meet one of these in the table. And you could probably reduce in the insulation or the thickness of the insulation on the outside of the wall if you wanted to go that path. Now the R value method is still available. It hasn't gone away. It's still there. We'll get to that in a minute. But these are where all your U factors are, okay? So our F factors we're going to look at so if we look at footnote E here, F factors for slabs are going to correspond to the R values in N1102.1.3. Okay, and the installation conditions 1102.2.10.1. So a lot of energy changes, but a lot of it, I'm actually happier with the 2024 energy than I was with the 2021. We were enforcing the 2021 energy in the city and county of Broomfield, and it was a bear because there were so many provisions that, okay, now you got to do this, now you got to do this, and the builders hated us just because they're like, this is not cost efficient. Well, it's going to be cost efficient for your homeowner when they're not paying out the nose for their energy bills. But I think we've reached the point of diminishing returns with our energy code, in all honesty. And we'll see. I'll talk about that a little bit more here when we get to the R values. So if we're using the R value alternative, same thing, we've added in the F factor as with the U factor. Now, this is our residential code. This is the R value, okay? So obviously with Windows, they kept it, 0.5. let's go back a couple of slides just so you can see. So like if you're looking at vertical in climate zone 1, you're still 0, you're still 0.5. So those kind of things didn't change because we all know what the U factor is compared to the R value, right? They're the inverse of one another. So if you've got a 0.28, that's a SHGC, but if we're looking at a 0.5, something like that, the inverse of that is going to be what your R value is. So if we went from see, I'm in 5 here. So my U factor is now 0.28 that I've got to go through, and that gets me roughly R3, R3.5, which is why they keep the U factor in there, because otherwise it's like, well, that's so small. When in all reality, our windows and our doors are our leakiest portions and the most uninsulated portions of our walls. So if we look at, so if we're here we go, let's look at footnote G. A maximum U factor of 0.30 in marine climate zone 4 and climate zones 5 through 8, where they're installed above 4,000 feet, which is pretty much all of Colorado, or in windborne debris regions where protection of openings is required. Now, depending on where you are at, I know there's some portions of Nevada that are probably in 5, but I think most of you are in 3 or 4, if I remember right. Or 5. I know that you're spanning probably these 3. All right. Okay, so R factor, or R value, sorry, R value is going to be the same here. So if we're in 5, we're just going to go, because I'm in climate zone 5, I'll give you that example. We got to have 30, an R30 for everything above the direct deck. Now this is where we get a little crazy because the 2021 added this information into the table, right? So for my wood framed wall, I need a 30 or I need an R20 and 5 continuous. So this is where we're going to have, you got either use a zip sheathing with a 1-inch, an R5, or stucco on the outside of the wall with a they get with the foam that gives you that extra continuous. So there are give and take, but this is where I struggle with it because you start throwing in a 2x6 wall, you're not going to get an R30 in a 2x6 wall. That bat, even an R21 bat, is and if you do a high density bat, then you're getting 5.5 inches, and so you're barely fitting an R21 in a wall. Now we got to put an R30 in the wall. So pretty much you're either going to use a 2x8 wall or a 2x10 exterior wall, and then you're going to be putting in, or you're going to be putting continuous insulation on the outside. So I will say from a standpoint, from doing reviews and stuff with the new codes, we are looking at seeing more and more of the continuous insulation on the outside. Now, Hardy board, the Thomas Hardy board, does make a lap siding that has insulation on it. And it is able to be installed typically, so without any special provisions or anything like that. I think up to 1.5 inches is what the ES report says. I did run into that a couple of times when I was in Moab doing inspections and plan reviews there. And it's a pretty cool product, but it does give you that. It wouldn't be quite continuous, but it could be considered continuous because of the way that it gets applied. But this is going to give you more value. Now, that being said, all right, your continuous insulation doesn't have to be on the outside either. You could throw continuous insulation on the inside of the walls and attach the drywall over the top of that. It just has to follow some type of manufacturer's instructions or assembly. All right. Now, one of the others is we've got our floor values changed as well. So it's always been R30 in the code, but now we've got some continuous insulation that we're allowed to put on those to where we're separating spaces. So this would be an unconditioned garage to a habitable space above the garage, those kind of things, right? Heated slab and depth, that was a big change in this table. Obviously, you can see I pulled these from online where they've got the blue that shows the changes. So for me, I need an R10 continuous if I'm heating the slab, for 3 feet and an R5 on the whole slab. So an R10 for the first 3 feet and R5 for the whole slab. So I'm putting an R5 underneath the whole slab and then an extra R5 for the first 3 feet on the exterior of the slab. All right. Are you guys tired of energy? Because we're not done yet. All right. So we have a little more provisions of how we're supposed to install insulation in floors. It's got to be in accordance with all of the following. Okay. Of course, our first one, manufacturer's instructions and table R421.2 or 402.1.3. Floor framing members, part of the building thermal envelope, shall be air sealed to maintain a continuous air barrier. So this is where you'd have a cantilever porch over or a bay window, something like that, where the floor system extends out past. And it has to meet one of the following methods. So if we look at that back of that last slide, those are brand new changes in the code, as well as this. One of the following methods: cavity insulation maintained to permanent contact the other side of the subfloor decking. So that means you can't just leave this gap here. It's got to be uptight, right? Cavity insulation shall be installed to maintain contact with top side of the sheathing, separating the cavity and the unconditioned space below. From the bottom to the top of all perimeter framing members. So this is what that's talking about right here. Gotta make sure it goes all the way up, all right? And then a combination of cavity insulation and continuous insulation shall be installed such that the cavity insulation is in contact with the top side of the continuous insulation. So if we look at this picture here, we've got our rigid continuous, right? And then we've got our chipboard down below and our subfloor here. So this insulation needs to be installed this way, right? It's got to be continuous insulation shall be installed to maintain contact with the underside of the structural floor system and extend from the bottom to the top of all perimeter floor framing members. All right. Basement wall insulations. So where basement walls are insulated, the top of the basement wall all the way down to 10 feet below grade, or the basement floor, whichever is less, right? So I don't know about you, but I didn't see many basements that were over 10 foot tall. So we were always insulating the whole thing. Or we can add it into the 2024, or we can do this in accordance with the proposed design or rated design as applicable. Okay, so if you've come up with or you find some type of design, whether it comes from UL or one of the other agencies that works for these basement walls, you can use that and put that in your plans. But we're going to need to see whatever that design is based on and have the information and details pertinent to it in the plans. So our plan reviews are getting more and more energy involved as we're doing these things. All right, so we've got our energy efficiency for our air sealing and air barrier. For insulation, we've got a couple of added sections. So we added knee walls, and the code actually added a new definition for knee walls. Knee walls, air barrier between conditioned and unconditioned space. I used to run into this a lot when I was doing inspections in Moab. We'd have, one section that's a raised ceiling where they've got the kitchen or living room or open area in a home, and they would just throw bad insulation in there and said, well, where's your air barrier? Because that attic's not conditioned. You got to have some type of barrier there. And so they'd usually put on scrim facing or vinyl facing or foam or foil. Sorry, foil. And so you see that a lot. It's just entering into the code more in an explained manner, I should say, because a lot of us that have got trained on the energy code in the beginning were able to make those connections, but now it's just becoming clearer in the code that, hey, you need this, where it wasn't clear before or included in the code in a clear and concise manner. All right. So just some updates on languages here. Like if we look at windows and skylights, the rough opening gap, obviously we need to fill that with foam or some type of sealant in accordance with the manufacturer's instructions. So a lot of times you'll see these guys, at least when I was doing inspections for installation, they would take that spray foam, that expanding foam, and spray it into that gap. And the problem with that expanding foam is it expands. And if you're using vinyl windows or some other type of window that doesn't have like great structural integrity, it's able to flex a little bit. You can actually, if you put enough foam in there, get those windows to bind up so that they don't open and roll and smooth, and open and close smoothly. And so that's where you got to rely on the manufacturer's installation instructions on how they want to do that, whether you caulk it or whether you chink it with foam or anything like that. So continuation of this table, we're looking at spaces. So showers, tubs, and fireplaces adjacent to the building thermal envelope. Got to have an air barrier separating the insulation of the building thermal envelope from the shower tub or fireplace assemblies. So we're seeing a lot of times that you got a fireplace on the outside wall. The void just gets left open and there is no air barrier in there. And so there creates a leakage around the fireplace into that and outside. All right. Electrical boxes, housing closures penetrate air barrier. They need to be caulked, taped, or gasketed. So HVAC register boots. So if we were to go back one slide here, obviously we're looking at installation criteria here. We're looking at HVAC supply and register boots located within the building thermal envelope shall be buried in or surrounded by insulation. So if you're coming from the attic, those should be completely surrounded with insulation. Just in the thermal envelope assembly. So if you're 2 floors, if you got the basement and a first floor and your boots in that, obviously that's within the thermal envelope. That's not your exterior wall. You're not having to worry about that in those ones. All right, and common walls are double walls separating detached single family or townhouses. So this is a completely new addition into this table where we have an air barrier between the intersection of the building envelope. And it should be installed in a fire resistant weighted wall. And they got to comply with one of the following. Pretty much got to be in accordance with the fire rated assembly and also showing data that shows that it complies with the required fire resistance rating. All right, air leakage testing. So how many, I wonder how many of you actually put that we need to air leakage test on your plans. It is required by the code unless you meet some of the exceptions where the code allows you to not do it. But the building or each dwelling unit or sleeping unit, so we've added or sleeping units into this code, shall be tested for air leakage. Now this section pretty much had a pretty well a full overhaul, where we renumbered things and changed the location of it. Okay, same thing with the new exception. We added in the building thermal envelope into the exception 1 for heated attached private garages and private garages accessory to 1 and 2 family dwellings. Building envelope needs to be tested, and it needs to be tested in accordance with section. So if you test it in accordance with section R402.5.1.2.1, each dwelling unit or sleeping unit is not required. So testing each of them. So this would be where you've got a hotel or other type of R occupancy where you've got a sleeping. So if you're doing a bed and breakfast, that kind of stuff, if you meet the provisions of R402.5.1.1.2.1, you wouldn't have to test each individual sleeping area or dwelling unit individually. All right. So new. Yes.
I'm sorry to interrupt. We have 2 questions, 2
Sure.
long questions, the Q&A.
Oh no, not energy.
Let's see. The first one. At the radiant heated concrete slab, does the new code allow for the foam insulation to be 100% below the slab and then vertically only at the perimeter edge to prevent a thermal bridge from the slab? It's very long. I don't know if you maybe want to rephrase it because
Yeah, no, I can look at it.
okay,
So
it's yeah.
radiant heated concrete slab. Does the code allow for foam insulation to be 100% below the slab and then vertically only at the perimeter edge to prevent a thermal bridge? Okay, from the inside of it. Can this be used to limit the insulation in the vertical face of the stem wall? 3 foot
All
at
right.
least.
Thank you.
So in my experience, we did allow that, and there is an exception in the table that allows you to do that. So let's see if it is unheated. Here we go. C. So C says slab installation still being installed in accordance with N1102.2.10.1. So let me see. Because usually it used to say in the table that this is where you could do it. And so I am usually it's not doubling up. So if you've got your, let's see here, you've got your where is the perimeter value? Installation above entirely to deck, basement wall R value. So in mine, we're always there. Okay, here we go. The unheated slab R value in depth. So this would be your 3 feet 10 R10 on the continuous here. If you're following where my mouse pointer is right now, right here, this is where your unheated slab is, the 3 feet. So if I'm looking at your question, right, let me pull that up just to make sure. Prevent a thermal bridge from the slab to the inside face of the stem wall. I would say yes in answer to your question. So since the unheated slab is using the R is the 3 feet, this 3 feet essentially means that you could put that. So the code has always allowed you to do a couple of different combinations with how you do the installation. So if you've got 3 feet at the perimeter, you can eliminate that for the extra at the slab edge. Now that doesn't mean that the mechanical code won't require an extra 5. I think that if I remember right, the mechanical code requires an extra R5 for 2 feet, just based on if you're using hydronic heating. But you would be able to eliminate that extra R3 on the outside. We would need to obviously still keep our thermal break. So that's the whole intent of the code, is to keep the thermal break so that we don't have a direct transfer of cold or heat from outside. Does that make sense? Let's see.
I'm waiting for an answer. I haven't seen it.
Yeah, I hope it makes sense because in my mind, that's just a doubling up. You wouldn't need the 3 feet on the outside as well as the 3 feet on the inside of the slab for it being heated. He said thank you, so I think we're good. All right, let's do this other one. Regarding continuous rigid exterior wall stud and moisture bearer, does the rigid insulation attached to the stud with a sheathing panel applied over the rigid insulation attached through rigid to stud comply with energy code? Yes, and so that is what we're looking at. So Rick, your question here, that essentially is what we're talking about here with our rigid insulation attached to the stud with a sheathing panel. That would be where, because I know that zip sheathing has a certain type of sheathing that you can get that actually has the R has a certain type of R value on it. You can get it. I think it even ranges up to an R15. I think they got 3-inch insulation. When you're installing that, that's obviously underneath the sheathing and on top of the stud. Yep. So and that would be what you said there is the vapor barrier and drainage mesh applied over the dense glass type sheathing for stucco. Yes, correct. That would be right there on the outside. That would apply with energy code, and that is the complete intent of that code, is to make sure you get that continuous R value in there to reduce what you need. So creating, essentially what we're doing is we're talking about thermal breaks. We're creating a thermal break from the exterior wall to the studs so that your studs don't directly transfer heat through the sheathing. And that's all the code's wanting right now at this point.
Okay, so Rick says, good to know, thanks. There's another question. Are there any exceptions to R312.2 window fall protection?
Yes, so if you go to look at that section, if your window is above a certain height, 24 inches off the floor, then you don't have to worry about fall protection at that point. What they're worried about is somebody leaving the door open or where a bed might be. So you got the window here and a bed here. They don't want somebody rolling off the bed out the window or a small child being able to crawl out of the window. And so there are certain areas where that will apply. It doesn't always apply. And I can pull up the code section here. Monica, if that's okay, if you're okay with me stopping the share for a second here, we can actually pull up the 2024 code section.
Sure.
So I'll leave this on this slide for a second while I pull that up. I usually have the codes up with me while I'm doing this too, so. Here we go. 2024. Let's go to, oops. Let's go to our 312, and we'll just pull up those exceptions right here. Or R, let's see, what did he say? It wasn't R312. Have we got more questions coming?
I don't see any more.
Okay, perfect. So that's one of those where R312.12 changed to. So R312.12 is not in the 2024 code. R312 is now minimum room areas. So this is where we were talking about the restructuring. So we're going to be looking at our guards and window fall protection. It'll be a 321 now. All right, so let me pull this up here. Window fall protection. Okay, 321.2.1. Let me pull this up here and pull this out. We're going to do a different share here. So let me pull this code up so we can go through this together. All right, here we go. All right, did that work?
Yes, I see it.
Perfect. So we're looking at guards and window fall protection. So 321.2 is where we get into fall protection. So in dwelling units where the height of the clear opening is less than 24 inches above the finished floor. So 24 inches here above the finished floor, and then you got to have 6 feet below outside the window, okay? Greater than 72 inches. Then that's when the requirements for that lock device and opening prevention device kick in. So they can't open more than a 4-inch sphere to pass through, and they just have to comply with the ASTM F2090, okay? So that should answer your question. Oh, it doesn't say name, it just says guest. So they're not required on all windows. So there are certain provisions that kick in. 24 inches above the floor or less than 24 inches above the floor, and you got to have a drop more than 72 inches on the outside. So if you throw in a window that's 18 inches above the floor, but you've got a second story roof or an eyebrow roof, whatever you want to call it, a porch roof that is less than 72 inches below that window, you're not going to have that window guard because you're not going to fall more than 6 feet. Does that make sense? I ran into that a few times where like, well, I have to have the window guard or the window protection and not be allowed to do that. Or not have the window open more than it needed to be. But you would be able to get away from that if you had a porch roof or a second story roof or something like that where you're not going to fall out the window very far, maybe only a foot or two. And apparently per OSHA, you have to fall 6 feet if you're going to break anything. All right, let's go back to sharing the presentation. While we're answering questions, are there any other questions that anybody wants to ask real quick?
Don't see any other questions.
Perfect. I was going to give it just a minute and see if we're getting down to the wire. We're almost done, but we're not done with energy. So I apologize, everyone, because a lot of these changes for the IRC did end up being energy. Some of the big ticket items obviously were energy. All right, where were we? We were past this one. Oh, we were talking about testing still. So were we here? Yes, tested in accordance with bar 402.5.1.2.1. Not each unit is not required. Okay, so this is where we're talking about unit sampling. Okay, so if you're gonna take, you've got multiple dwelling units or multiple sleeping units that you're going through, whether it's an R3 boarding house or something else that we could build out of the IRC, six or less for a boarding house. Then you've got, if you got 8 or more dwelling units or sleeping units, 7 or 20% of the dwelling units, whichever is greater, shall be tested. So if you've got 8 units, you've got to test 7 of them. So you get one free. You don't get to take all of them off. If you have 10, then you have to still do 7. And they got to be, oops, I keep touching my mouse wheel, I apologize. Middle floor unit, and they got to be sampled in a specific way. So if you've got multiple floors, you got to pull middle floor unit, end unit, those kind of things of where it is. It's just telling you how you get those exemptions for unit sampling. Pretty simple, straightforward. Obviously, if we're doing testing, it's got to be in accordance with ANSI Resident ICC 380 to the 2019 for the 2024 and 2021. All right, maximum air leakage. So if we're testing in accordance with R402.5.1.2, the air leakage rate for buildings are going to be as follows. So if we comply with R401.2.1, this is obviously from the IECC, not straight out of the IRC. So if we were to go 1102.5.1.1 is what that would be. Building dwellings in the building not air leakage rate greater than 4 air changes per hour in climate zone 0, 1, and 2, 3 for 3 through 5, and 2.5 through 6 through 8. So there are portions of Colorado where we have to do the 2.5 air changes per climate zone 6 through 8. Some of those portions of Colorado that are higher up in the mountains are actually in a 6 or a 7. So it gets a lot of fun when you're doing plan reviews between the different jurisdictions here in Colorado. And where you're complying with R401.2.2, so that would be 1101.2.2 or 1101.2.3. So 1101.2.1 is going to be your prescriptive path, and 1102.2 or 1101.2.2 and 1101.2.3 is going to be your total building performance or your ResNet or your ERI, energy rating index, or your what's the other one? Is it ResNet? One of those the energy rating indexes. That's where those two are going to come in. So if you're complying with just a prescriptive method, 3 or a 4, 3, or 2.5, depending on your climate zone. And if you're complying with the total building or the simulated building performance, then you're going to be not greater than 4 air changes per hour or 0.22 cubic feet. All right. And that's regardless of what area you're in. All right. All right. Now there are a couple exceptions where an R2 occupancy without simultaneously testing adjacent units, you're allowed a little bit more, not permitted greater than 0.27 per square foot. The same thing, 0.27 per square foot of testing unit enclosure area. And where you have more than 1,500, where you have 1,500 square feet or less, sorry, of conditioned floor area, the rate is permitted to be not greater than 0.27 cubic feet per minute per square foot. Oh, that's a mouthful. 5% through ceilings. So this is how much you're leaking out of your different areas. So obviously the basements are doing pretty well, right? Through the basement floors, but you got 20% through the basement walls. That's what we're trying to keep back on and make sure that when we make houses tight, we're not leaking everywhere. Now, back in the day, if you look at a 60s house, it leaks like a sieve. I had an apartment when I first got out of college that and you could literally sit in front of the couch right below the window, and there would be a draft on your back if the wind was blowing, even though the windows were shut. And we were just building houses a lot tighter. So this also kicks into needing to have a ERV or an HRV, something that pulls air in and out of the house, so we get some air changes, so there isn't just stagnant air in the home. All right, so air sealed electrical and communication boxes. This is where you're going to get the engineers, and they'll need to call out for and specify an electrical box that will work with the vapor retarder and that kind of stuff that you've got in your home. Now those have to be, they're called air sealed electrical boxes now, and communication boxes, and they just have to, where they penetrate the air barrier, they got to be caulk taped and gasketed. They got to be tested and marked within NEMA OS4. So the NEMA OS4 requirement was new in the 2021 code. Oops, sorry. New in the 2021 code, and they just expounded on it in the 2024 code. And they got to be installed, obviously, per manufacturer's instructions. Pretty simple, pretty straightforward, right? Duct systems. So they did quite an overhaul of duct systems in the 2024 code as compared to the 2021. They just got to be sized in accordance with M1601.1 of the IRC or 603.2 of the IMC. And they've pretty much named them duct systems now instead of using ducts or duct ventilation, those kind of things. Okay. Now we got to do have an exception if it's not integrated with duct systems serving heating or cooling systems. Okay. So if we got a duct that doesn't actually push hot or cold air, that's not meant for heating a room or cooling a room, then it doesn't have to comply. Systems for 1 or 2 dwelling units must be designed in accordance with ANSI/ACA Manual D. So that's where we're looking for. With the 2021 and 2024 codes, we've been asking for manual Ds to be submitted with the manual Js. So we need a manual JD and S. S is just your equipment, but the D we should be looking for, and those should include as well on the design side. They should include the fittings. So whether you've got corners, turns, your boots, those kind of things. Those should all be included in your manual D. All right, ducts in conditioned space. We have some updated conditions. Ductwork contained in the wall or floor assemblies, separating unconditioned from conditioned space, have got to comply with the following. We got a totally new updated section. So as part of the building assembly installed, ductwork and the between the ductwork and the unconditioned space, ductwork should be installed in accordance with 1103.3.3, and we can't have less than an R10. Not less than 50% of the required installation R value in table 1102.1-3, whichever one's greater. And then also segments of ductwork contained within building assemblies not considered completely inside conditioned space. Okay. So if we got a basement and a first floor, and we're putting all the ductwork in between those 2 floors, that's within the thermal envelope, that's within the conditioned space, and so we wouldn't need to comply with this information. Obviously, we'd have to seal it up, but we don't have to put duct insulation around it. Now that R10 is a change. It used to be an R8, so we've gone up another 2. Duct testing, this is where you do your duct blaster, those kind of things, and we just need to make sure that those are listed on the plans and called out for. So we do have some new parameters, and that obviously that information needs to be provided to the code official. As a designer, you might want to see it as well, or call out for it to be one of the tests that needs to be done. All right. So exceptions to duct testing, obviously, If it's not serving a heating or cooling system, it doesn't have to be tested. Not more than 10 feet of total ductwork external to the space. And duct is located entirely within the conditioned space. If both of the following are met. So this 10-foot rule has to be entirely within the conditioned space, and it doesn't include any plenums or building cavities or gypsum board.
Cole, we have about 5 minutes. And
All right, I was just gonna say you guys are probably tired of energy, so let's just call it there. And I will say that as far as the mechanical, electrical, and plumbing provisions of the IRC go, there weren't much changes. There weren't many changes for the 2024 from the 21 to the 2024 code. Not significant anyway. There were some restructuring, and some clarifying items, but not too terrible. So I think we'll just quit there. And if you got any questions, let me know.
we do. We have two questions.
2 questions. Perfect.
So from Ken Rose, can different insulation systems be combined to achieve the required R value?
Yes, so that's perfect. So we could use you can use spray foam, polyiso, or closed cell foam, that kind of stuff. You can use all of that and then put a bat on top of that to achieve that rating. So we could get an R30 out of a 2x6 wall if we did spray foam and a bat on top of that, or we filled it completely with spray foam. Because you can get, let's see, spray foam is roughly an R7 per inch, and so you can get an R30 out of that.
Okay, the next question is, can window frame air intakes in combination with the timer control fans be used instead of HRV units?
Yes, I have actually seen that used before, to where you're able to exchange the air. The only difference with our HRV is it robs the heating and cooling off of that. But window frame, yeah, that could work. I've seen those in, so I had these just real quick. I know I had these super green builders in Moab that loved to build out of straw and do all of that kind of stuff, straw and plaster and all that jazz. But they would put these little not box fans, they were like little tubes that basically just opened on a timer and sucked air through the house. They'd put them on opposite ends of the house and pull air through. And those were allowed by code, so. Hopefully that answered your second question there, Tom. When and how. So that would be a section where it could be allowed, to where it can transfer air in and you get a few air changes per hour or X, Y, and Z. It would just have to be integrated in with the HVAC system and approved by the building official. And so that's really what it comes down to, is with all of this information, it depends on the jurisdiction having authority. So the AHJ is going to be the one that says, yeah, you can do that, or no, you can't do that, because it's all in the eye of the building official. Now, there are more guidelines and things like that in the 2024 that say, hey, building officials, you have a little more leeway with what you can get away with or what you can approve, as long as you've got this supporting documentation. But it is always up to the jurisdiction.
Okay, I don't see any more questions.
Right.
Yeah.
Okay, perfect.
One more. So.
Okay.
All right. Cole, do you want to share your contact information or anything like that? If do you have that? I think I've seen it on one of
It might still be Steve's at the end of this. Let
Oh,
me
is
see.
it? Okay. Yeah, it's always good.
Yeah, it's still Steve's. So my email will just be cole.cl